Hello, Assalamu alaikum. This is me, Muhammad Wasikam. Today we will discuss about a very misleading question. The question is about light. In the previous centuries, our concept about light has changed from the particle nature proved by the Newton to the wave nature proved by the Young's double slit experiment, and then again to the particle nature again proved by the Einstein by explanation of photoelectric effect. And at last, the recent concept of light is the wave particle duality, or we should say that light is both wave and particle at the same time. Now, the main uh, question of this video that I will be addressing is that does light follows relativity, or I should say, does light follow the special theory of relativity? The answer is light follows special theory of relativity, not completely, but to an extent. The extent to which light follows special theory of relativity is only the first postulate of the special theory of relativity that you can see here. That is, the speed of light is constant in a medium or vacuum for all reference frames, and that is the only principle that light follows of special theory of relativity. And the other principles like time dilation, length contraction, mass dilation is equal to mc square, light does not follow them in a way uh, other particles with mass follows. So the main question that arises is that if light particle or wave travels with the speed of light, or we should say the constant c, does the light mass goes infinite? As you can see in the equation, m relativistic mass is equal to rest mass over lambda rest mass over 1 minus v square over c square. If you put velocity equal to speed of light, then we have rest mass over, what do we say to it, 0, and the relativistic mass of light should come to be infinite by this equation. So light should have infinite mass as light travels with the speed of light according to relativity. But this is not the case. The relativistic mass of light is not infinite. The relative light has a relativistic mass, but it is not infinite. It is, we should say, very low. Or the main equation that governs the relativistic mass of light is not this equation. It is this equation that you are seeing right here. In this equation, you can see that mass is equal to h over pi lambda. This is the main equation that governs the mass, the relativistic mass of light. But how it is possible? Is it the drawback of special theory of relativity? You can say to some extent, but it is not a drawback of special theory of relativity. Special theory of relativity also explain why light has no, why light does not have infinite mass when it travels with the speed of light, as light travels with the speed of light. So why light does not have infinite mass as it travels with the speed of light? So the explanation is right here that you can see, and I am the one who is solving it. So we have rest mass over 1 minus v square over c square is equal to relativistic mass. So let's put the values. Put the value of v is equal to c. So c square over c square comes to be what? 1. 1 minus 1, 0. And after that, rest mass over 0. What is the answer now? Now, most of you will say it is infinite. But let me say it is not infinite. Why? Because the rest mass, what is the rest mass of light? The rest mass of light is not any value as we have mass. The rest mass of light is zero. So what do we get here? Relativistic mass of light comes out to be 0 over 0. Now, what is the answer of 0 over 0? Can you tell me? The answer of 0 over 0 is not infinite, because 0 over 0 is not an infinite form. It is an indeterminate. For those who do not know what indeterminate is, indeterminate means that a mathematical form that can have more than one answer, or we should say many answers, because 0 1 zar is also 0, 0 0 zar is also 0, 0 2 zar is also 0, 0 0 900 zar is also 0, and you can extend this value but not to infinity. Okay, so that's the case. So what does this equation says? This equation says that light can have any value of relativistic mass depending upon the equation that I have shown you previously. M is equal to h over lambda c, depending upon what? Depending upon the wavelength of light. So the relativistic mass of light depends upon the wavelength of light. Understanding my point? And as the wavelength of light can change, the relativistic mass can change from any value. As same like that, 0 over 0 can have any value. Understanding my point?